The atom, theories and models. The atom. The basic idea that matter is made up of tiny indivisible particles is an old idea that appeared in many ancient cultures. The word atom is derived from the ancient Greek word atomon, that is, uncuttable, indivisible. This ancient idea was based in philosophical reasoning rather than scientific reasoning. In the early 19th century, the scientist John Dalton noticed that chemical elements seemed to combine with each other by discrete units of weight, and he decided to use the word atom to refer to these units, as he thought these were the fundamental units of matter. About a century later, it was discovered that atoms are not actually indivisible, but the term stuck. The atoms are made from more fundamental particles in our current understanding. Herewith is the progression of our understanding of the nature and composition of an atom. Atomism. Year, 400 BC, proponent, Democritus. He put forth the idea of atomon, or indivisible minute and indestructible particles, whose many shapes and forms constitute the different states of matter. His argument for the existence of atoms hinged on the idea that it is impossible to keep dividing matter infinitely, and that matter must therefore be made up of extremely tiny particles. Atoms are the building blocks of matter. The shape of atom explain elements' behavior. Solid sphere model. Year, 1803, proponent, John Dalton. His theory stated that atoms are indivisible, those of given element are identical, and compounds are combinations of different types of atoms. Pros, recognized atoms of a particular element differ from other elements. Cons, atoms are not indivisible. They are composed from subatomic or more fundamental particles. Plum Pudding model. Year, 1904, proponent, Joseph John Thomson. He discovered electrons, which he called corpuscles in atoms in 1897, for which he won a Nobel Prize. He subsequently produced the Plum Pudding model of the atom. It shows the atom as composed of electrons scattered throughout a spherical cloud of positive charge. Pros, recognized electron as component of atoms. Cons, no nucleus, did not explain later experimental observations. Nuclear model. Year, 1911, proponent, Ernest Rutherford. He fired positively charged alpha particles at a thin sheet of gold foil. Most passed through with little deflection, but some deflected at large angles. This was only possible if the atom was mostly empty space, with the positive charge concentrated in the center, the nucleus. Pros, realized positive charge was localized in the nucleus of an atom. Cons, did not explain why electrons remain in orbit around the nucleus. Planetary model. Year, 1913, proponent, Niels Bohr. He modified Rutherford's model of the atom by stating that electrons moved around the nucleus in orbits of fixed sizes and energies. Electron energy in this model was quantized. Electrons could not occupy values of energy between the fixed energy levels. Pros, proposed stable electron orbits, explained the emission spectra of some elements. Cons, moving electrons should emit energy and collapse into the nucleus. Model did not work well for heavier atoms. Quantum model. Year, 1926, proponent, Erwin Schrödinger. He stated that electrons do not move in set paths around the nucleus, but in waves. It is impossible to know the exact location of the electrons. Instead, we have clouds of probability called orbitals, in which we are more likely to find an electron. Pros, shows electrons don't move around the nucleus in orbits, but in clouds where their position is uncertain. Still accepted as the most accurate model of the atom. As scientists learned about the structure of the atom through experiments, they modified their models of the atom to fit the data. British physicist Joseph John Thomson understood that atoms contain positive and negative charges, while British physicist Ernest Rutherford discovered that an atom's positive charges is concentrated in a nucleus. Danish physicist Niels Bohr proposed that electrons orbit only at set distances from the nucleus, and Austrian physicist Erwin Schrödinger discovered that electrons in atom actually behave more like waves than like particles. Until about 100 years ago, the atom was thought to be the smallest unit of matter. Since then, scientists have discovered that atoms consist of a number of tinier, subatomic particles.